Then under acceleration, I mentioned to say we've got what we call the opposite of acceleration. So the opposite of acceleration is retardation. They can say retardation or deceleration. Aye. Okay? At the opposite of acceleration, it is retardation or deceleration. Now, how is it written? So you see that, when it comes to this one, I've got a very, very beautiful formula that we have. Okay? We have this particular very nice formula, which we say retardation or deceleration indeed. They will write the word like deceleration or retardation. To retard is to slow. To retard is to slow, but to accelerate is to speed. So opposite of speed is slow. You get accelerate, retard. That's what sometimes they say, no, I think this one is mentally retarded. You get that? Yes, it's not that, Alright, so let's see how we got on this one. So opposite of acceleration is retardation. Retardation, take note. So retardation, in a sense, it is the opposite of acceleration. Take note. Yeah, but I mean a concept. So retardation is basically the opposite of acceleration. So you see that retardation will equal to negative the acceleration. Can you say retardation is basically the opposite of acceleration? So when you get the acceleration, we're going to get the retardation. Are we catching? That is the idea. And you have this in mind, please. Have this particular very vital important formula here. It's a very, very important thing. Meaning, acceleration, if you get a negative acceleration, what is it? A negative acceleration. It is retarded. So the moment you get a negative acceleration, it is actually a retardation. Take note. That's very, very good. From this formula here, you get that. That's what you do. Okay, let's see now how we go about this in a practical sense. So here I can even highlight something for you to say, actually, a negative acceleration means retardation. Take note. The moment you see negative acceleration, just to say it's actually retardation. Say, for example, you are calculating the acceleration of the line. Now it happens that acceleration, now the answer that you get is a negative one. Just want to say, oh, that negative is the acceleration, but that's actually a deceleration, because that acceleration is actually giving you the negative number or answer. So that is, in a sense, a retardation. Are we there? Let's see now how we go about it. Actually, going by the examples. I've got a beautiful example here which we're going to employ the same concept that we've actually seen here. Okay, so like I mentioned, travel graphs, they involve velocity time graph and speed time graph. In it, we have got concepts like acceleration, which is defined by rate of change, in velocity with respect to time. And we also learned that acceleration can also be computed by using the gradient method of formula dy dx, changing y coordinates over changing x coordinate, which will give you acceleration. It's very interesting, trust me. It's very interesting stuff. As though that is not enough, we went further and looked at the speed and the velocity having the same units meters per second, same units meters per second. And of course, we went further to say, suppose you are asked to calculate the distance. So for you to calculate the distance moved by either an object or a person, you simply can employ the concept of the area of that particular shape. You calculate the area of that particular shape, or simply put the area under the graph. That is what we call the area under the graph. So you pick the shape of that figure. That shape will tell you, if it's a triangle, it will be 1/2. The area of the triangle is 1/2 BH, breadth times height. And by computing the area, it will be actually computing the distance. If it's a trapezium, we know it is 1/2 the sum of the two parallel lines times the height, the perpendicular height. They will still give you what? The distance. So just however the shape is, it can be a rectangle, a square. Calculate the area of the square, which is L squared. Rectangle, LB, length times breadth. And of course, that's how you go about it. And of course, we went further and did explain the issue to do with the collinearity of lines. If any two or more points are collinear, they are said to be lying on the same one straight line. That's what it is. And their gradients at any point will be equal. Forever and ever and ever will be equal. However they are, so long as they are lying on the same straight line, the gradient will be equal throughout. Yes, that's what it means. And of course, we went further, we said, we also borrow the concept of synarity and congruence to, of course, appreciate some of the questions, how to go about it, solving some of the, questions. So now let's see and get started and look at it, examples.